Hi, this is Brendan O'Mahony from Broma Engineering, and today we're going to be talking about AHUs. This is episode 6 of the Data Center Equipment series. Welcome to today's episode. Okay, so what is an AHU? An AHU is an air handling unit, and it's used to push air through the white space or the data hall, and it usually cools the air as well. So I'm not going to go into how an AHU works on this episode because there's plenty of videos on that on YouTube. So look one of them up if you want to know how it works, and I recommend you do know how it works. So an AHU is either going to be use chilled water, or it's going to use evaporative media. These are used a lot in commercial buildings to cool offices. So this is huge applications, pharma, factories, all sorts of things. So what you learn here can apply to any job. Okay, so for commercial use, it's usually going to be a chiller. You're going to use chilled water to cool the air going through the AHU and out the other end towards the habitable space, or even if you're in refrigeration, might even be colder. In data centers recently, it's gone to evaporative media using processed water, using adiabatic cooling to cool the air. This is much more efficient for energy-wise. Uses a bit of water, but not that much. There's a lot of rumors that data centers use a lot of water. I don't see how they do. Evaporative media is going to use a lot more water than a chiller because this is a closed loop system and this is an open loop system. So you're actually creating steam, well, not steam, but moisture, vapor. Sometimes it's visible in the right conditions, just like a cooling tower, and sometimes it's not visible. Sometimes in the morning you can see steam coming off a data center, or you can see the water moisture, or the water vapor, I should say. And sometimes you can't. That doesn't mean it's not happening all the time. It's running 24/7. So there's been a lot of rumors flying lately in the media that data centers use a lot of water. And I presumed that maybe in the States they had a different way of cooling data centers and they were using a lot of water. Because people used to come up to me and say, data centers use loads and loads of water. And I used to go, they use some water. I don't know if they use a lot of water. For evaporative cooling, there's obviously more water used than a closed loop system like chilled water. But still, even for an evaporative system, the water is going back into the air and turning into a cloud and falling back down on the ground again. It's not disappearing, it's not being destroyed. I think Irish Water, or Uisce Éireann, came out recently and gave a stat as to how much water data centers are using, because they can measure that accurately. Because obviously, if you get planning permission to build a data center, everything that goes into that's going to be measured very tightly. Obviously, to build a data center and for statistics in general. And they said there was, I think, less than 1%, but we'll check that out, of total water consumption in Ireland. Most of the water in Ireland is lost through leaks, and I know the system is being upgraded at the moment by Irish Water. I won't even get into what I think about Irish Water. But yeah, most of our water just leaks into the ground. So today I'll keep planners in mind, planning for an AHU and scheduling. I think that's probably the best way to look at this. It seems to be the most value people are getting out of it, understanding the process and how we plan this and why we do it in a certain way. Okay, so the first thing is level 1, probably the easy part, and you have your FWT and your FAT. So factory witness test, factory acceptance test. These are getting jumbled around recently. I always like to say, and it's a matter of opinion because there's no hard and fast rules, but a factory witness test is when everyone comes to witness. Factory acceptance test is when the vendor does the testing themselves. But recently people are calling FWTs FATs, of acceptance. For me, factory witness was always the big one, the first of a kind, the first AHU out of the factory. Everyone comes, everyone makes sure it's the right, and then the vendor does all the FATs after that. If you have 20 AHUs, number 1 is an FWT, the 19 after are FATs. Okay, so as a commissioning manager, as a planner, as a mechanical manager, we need to make sure we know when the FWT is happening, the vendor knows, the engineer of record knows, the client team knows, Any representatives from the GC, the mechanical contractor, whoever needs to go is invited to that. FWT, we know the location. We know that the factory is going to have it ready on time. We have everything we need there. They have power, they have a lab. We have a way of testing it on the factory grounds. And we've all booked accommodation and flights, and we're heading to the FWT. So we have FWT scripts for AHUs, many of them, if anyone wants them. And I'm not going to get too much into the FWT because it's not really the hard part. I suppose once the FWT is complete, logistics team need to understand what are the shipping terms, where is it being shipped to, and with these AHUs, they're very big items usually for a data center. So we need to make sure they're not going to hit any bridges or signs on the way. So the vendor usually is in charge of getting it to site and understand your shipping terms. You need to know where it's being dropped off, who's taking responsibility, who's unloading on site, where are the trucks going to, are we craning it onto the roof, are we sliding it into a room, do we need to leave some of the facade off, do we need to take some of the steel work down, do we need to tell the structural guys that we need special connections in the structural steel in order to remove panels, do we have to close the building up because it's the middle of winter and then open it up again, are we putting a special door in, a temporary door, or is there a door in the facility that's big enough to roll the equipment in all the way? So you have to talk to logistics, have to talk to your CSA friends. Is the ground outside strong enough to roll the truck up to it? Is the loading, we're probably not going to be using a loading dock for this, it's too big. Is it upstairs, is it downstairs? Do we need to crane it over anything? Do we need to close off areas? So that's going to impact other works, it's going to slow them down. So you need your scheduler involved with this as well. And what's the difference between planning and scheduling? The subject matter experts are planners and the scheduler puts it all together in a logical manner. We all need to work together to make a proper schedule on P6 or whatever software you're using, it doesn't matter. The end result is a Gantt chart that's easy to read. Okay, just back to level 0 or pre-construction and level 1 and getting on to level 2. We need a technical submittal approved, so we need a specification. Usually AHUs will be OFCI, sometimes not. It's becoming more common that they're CFCI, but usually in the past they've been OFCI, so that's owner furnished, contractor installed. So the owner of the building or the developer has already purchased these AHUs. You want to make sure that the technical submittal exists and it's approved, or if not, it needs to get approved. You need to understand who's going to approve it. So usually it's the design team and the engineers involved, whoever wrote the specification. And needs to be set in place in the model, so that needs to be put in place in the federated model that makes sense. The pipes need to be modeled up. Ductwork needs to be modeled up, if there is ductwork. Usually will with an AHU. And we need to make sure that there's comms cables and LV cables and that they're routed properly and that they're sequenced properly. Okay, so the truck has arrived on site. Security's on the gate. They know, they've been informed the truck's coming today. There might be a batch of 3 or 4 coming in one day, maybe more. It depends on how many you can bring in one day. And then security leaves them through, and then they're put into a holding area. This is in a perfect world, and the logistics team will do a receipt incoming form, RIF. And this is to make sure that the goods have not been damaged since they left the factory. There's been no water ingress that you can see. Sometimes these are wrapped in plastic, so you won't be able to see if there's water ingress at this stage until you unwrap it. So you're saying, look, the equipment is as shipped, it hasn't been damaged on the way, we can accept it from here and bring it into the site for lifting into position or rolling into position. So the RIF, the receipt incoming form, is going to be on your CDE, your Common Data Environment. That's a Procore, ACC, Autodesk Construction Cloud, wherever it is, it's ready to go. Make sure it's approved, ready to go. It's up on the system. We're able to pull one down and put it against this equipment. We're making sure the tag number is correct. So it's AHU, to make it very simple, 01. This is the one that goes into the back of a room in here. I suppose we have a row of them. We don't want to bring in AHU number 2 first and put it here. Then we're going to have to change the nameplates and serial, you know, it's going to be a mess making new nameplates. So be careful if you need to sequence them. Sometimes you won't. You'll be dropping them onto a place where you can move them around. But if you're rolling them in through a door, we'll say over here, you have to roll them sideways all the way down to the bottom of a cul-de-sac. Make sure your sequence is right. So check the nameplates. Always get the manufacturer to write the tag number on the outside of the wrapping, so you know which one is which before you unwrap it. There's nothing worse than being in the middle of winter in a mucky yard, unwrapping, trying to find a tag on the machine when it's pouring rain or snowing. So make sure that you tell the vendor to have this in big writing on the outside in a few places what tag it is inside. So some AHUs are so big that they come in sections and they might have to be assembled outside before they're rolled in, and you might need a crane to lift sections up on top of each other. So make sure that's accounted for in your logistics plan. And then we're going to roll it in. You might need to build a concrete plinth to sit them down on and roll them one direction, then roll them another. You'll need a specialized heavy lift and shift contractor to do this usually. Sometimes the vendor does it, but make sure that you know exactly what everyone's doing before this equipment, well before this equipment arrives on site. When you're doing your OFCI meetings, make sure your OFCI manager or yourself knows all this, that there's no scope gaps, that there's no argument the day before, the night before, the day of, slowing things down, holding things up. And okay, let's presume now we've got it into place. It's now set in place. You can do your set in place inspection, SIP. That's another form. It's unwrapped. We're making sure that the right tag number is in the right place, that it matches the model, that there's no damage so far when we've unwrapped it, that there's no water inside in it, there's nothing weird after happening, there's no bird after building a nest inside it or something. But hopefully it's gone from the factory straight to the facility and straight into place. So we're not storing it outside. Sometimes there's mold inside these things, so I'd always have, you know, dehumidification inside in the AHU during shipping, because when it was wrapped it might have been quite humid, and then that humidity is trapped in there for however long it takes to get to site. And if there's a delay, it might be stored outside for a few days with the wrapping on. It might be stored outside for a few weeks. Then you unwrap it, it's covered in mold. And some of these materials for the AHU, they're not designed to be in those conditions, so they can degrade quite quickly if there's not air flowing through them. So really make sure that all those things are covered with the vendor, and they have all the precautions taken for an unplanned storage. Okay, so I'm rambling on a bit today, but anyway, it's all good stuff, and it's important, and it'll save your team and your project a lot of time if you get it right first time. So now the set in place inspection is done, and a red tag can be applied. Sometimes the red tag is straight after the FWT, but these days it's usually after a set in place. And technical submittal is approved. The RIF is done and completed. I'd keep this as simple as possible, just what you need for this quality gate. Do not throw extras into this. Make this as easy as possible. Set in place done, RIF done. And of course the FWT or FAT is approved. Should be definitely done by now. And that documentation is all together in one package. Red tag, done. So anyone who tries to make a red tag complicated, just show them the gate. Say, pack your bags and get out of here. That's what I would do anyway. Red tag needs to go on easy. We need it to prove that quality is up to date. It's not kitchen sink kind of a tag. We're not throwing everything in there. We're not finished. We're far from finished. We've just got the equipment from the factory and set it in place. We're not checking everything. We're just checking what needs to be checked. So anyone who slows this process down is slowing down the project, is costing you money, costing you time, and it's a total waste. So be very careful with this. More is not good. Less is good. But what needs to be absolutely short check sheets, but relevant. All we're checking here is that the equipment is as it's supposed to be at this point in time. We're not checking anything else. Technical submittals, all that are supposed to be done by now. Level 1 is complete, red tag applied. Moving on to level 2, yellow tag. And this is installation. Now it's already set in place, so all we're doing really, now, again, think of it as a black box. If you're just thinking from a process point of view, everything's a black box. And this is an AHU. What have we got coming into it? We either have chilled water or processed water. Okay, depending on if it's evaporative. Chilled water if it's a chilled water system. Processed water if it's an evaporative system. We have LV cable. We have comms cable for the BMS. And then we have air with ductwork. No, maybe probably two bits of ductwork and ductwork to the outside. We don't know how many there is, but that's it. Air, water, power, comms, 4 things. To make it super simple, once all these are connected, you should be able to apply your yellow tag and do your final inspections. But of course, there's a couple of considerations we need to take. And this is where sequencing becomes really important. First of all, if you're rolling something that's very tall, so there's 2 AHUs and 2 sections on top of each other, so it's a 2-story AHU. The containment or pipes need to be out of the way as you roll that down that room. So from a scheduling point of view and from a design point of view, you need to account for that. So you could have them, pipes and cable tray off to one side and comms basket, and you can roll it down, or else you need to leave it down and put it in after. The pipes will be going. This is ductwork to the outside. Could be huge ducts to the outside, and there'll be louver panels. So planning this, talk to your teams, make sure that we know what's going on, what needs to be left down, who's going in first. So high level stuff should be going in first, and that should be reflected in the schedule. And every morning, the DABS meeting, we should know that. If meetings have started already, the daily commissioning meeting, then we should know what's going on in here as well. If there's a number of phases going on in one stage at one time, we should know what's going on as well. And maybe you can put some pipework in, maybe you can put some containment in, maybe you can pull some cables, but it needs to be accounted for, and you need to know what you're doing. I would say get as much in as possible before they arrive, but don't be taking stuff down on the day because there's a clash. So the roll-in routes in a perfect world will be mapped out in 3D, and you'll know exactly what's going to clash and what's not going to clash. So you're going to have to do planning sessions and brainstorming sessions with the teams and just focus on AHUs and see like what sequence are we going to put stuff in. And then you're going to connect to your LV, make sure it's the right cables, you've technical submittals approved for the cables and the containment. Same for the pipework, that you know exactly how pipework is going in, it's modeled in detail. So you've a high level of detail in that model. You know exactly what you need to do. It's not just a representation of a pipe. I'd actually just model it all at this stage. We have the technology, get it done, put the right joints in, get every component modeled so the team on the ground can use augmented reality or use computers on the site to know exactly where everything goes, and there's no confusion. It's a very powerful way of getting it done. Drains as well. Drains should be functioning by now. Check to make sure they're all working. Make sure the AHU isn't going to be sitting on top of a drain. Check that in the model beforehand. Make sure the as-built are correct. Scan the drains, scan whatever's in the room, and make sure it overlaps on the federated model as it is in real life. Sometimes the drain can be in the wrong position, it'll be under the AHU, and then you're in big trouble. You'll have to dig out the floor, and if you only figure that out when you put the AHU in position, yeah, that's not good. So now you've got a huge delay, you've panic, you've people breaking out concrete, rebuilding drains, and it's a huge headache, huge panic. Trucks are sitting outside in the rain, and you're inside with a breaking out concrete inside in a room. Check these things. Also, the pipe work, I would get it approved before installing. Sometimes pipe work can kind of be in precarious positions when they're going into these AHUs, and you don't want people having an opinion on it at the end for the quality inspections. At the end of level 2, you want this signed off, highlighted, a BIM review and the federated model saying this is the way the pipework's going to be. We've designed it as best we can so it's not going to get damaged long term. It's easy to maintain for operations. If it does get damaged, it'll be easy to replace it. All that good stuff. And make sure that that's covered. Engineers have signed off on it. We're not changing pipework at the end of level 2 when we have no time. So be very careful. Cross your T's and dot your I's in pre-construction. Get it all in there. Get it in there as part of a technical submittal. And don't try and slip it under people's noses. Try and, highlight it in meetings and say, look, this is what we want to do. We want to get everything signed off early. You'll have BMS panels and comms cables coming in. Model it in detail. Get it signed off. Tell people, look, we have it modeled in detail. This is the way it's going in. This is the way it's coming down off the basket, off the cable tray. Same with the LV connection. Understand your torque settings, torque marking, what torque you're putting on the cables. We'll do a whole QA/QC on cabling. Make sure the cables are tested on time, that the test team know the scheduling, that testing is in the schedule. And they're ready as well for level 3. Anyway, you have to plan the inspections at the end. There's no opinions in this inspection. We're inspecting what is in the model. We've built it as per the model. We've built it as per our technical submittals. It's in as per design. We've a detailed design. So there's any change now is a change order, and that's time and money. And you have to defend the case to keep this project on track. Now, if it's something huge and there's a huge design and there's a willingness there to spend the money, keep people on site for an extra few weeks, pay lots of money, that's perfect. But if that willingness is not there and there's change, that does not work. So from a contractual point of view, understand what you're getting into before you do a quality walk. So the equipment is nearly fully installed with LV, comms, ventilation and pipework. So now we'll have to organize our walk downs. In a perfect world, we're holding the schedule, and these are in the schedule and spaced out in a way that's reasonable. So early on, I would have these in the schedule. There's walk down, give time allocation for a number of AHUs, talk to people, make sure everyone agrees. The scheduler has it in as an activity, and we're getting ready for power on. That's the goal here now. Now, a couple of things to note. You will have LV switchgear upstream of your AHU, and you'll probably have more LV switchgear upstream of that, and upstream of that you'll have your MV switchgear and the transformer, and that's as simple as it's going to get. And into this you're also going to have a generator. So this is going to have to be complete. All cables tested, power on all the way up to here or here. It depends on the strategy for power on and the switching plan. So your senior appointed people, your SAP and your APs, are going to have to be involved in scheduling, understand this, what needs to be done, be there for the walk down, lockout, tagout. There'll have to be locks on the switchgear upstream, locks on the AHU if needed, locks on anything that can cause harm to anyone. So on the pipework, if it's high pressure, sometimes it's just easier to have it locked. If it's very low pressure, maybe there's no need. So LV switchgear upstream, all needs to be done, all needs to be tagged, and yellow tagged, everything done. So you could be waiting here if there's problems upstream. And that's why the main switchgear, I'll call it the MSB here, plenty of different names for that, we'll just call it the main switchgear because of the main switchboard. This is the hub of everything, really. This sometimes is called your house mechanical or mechanical distribution. This might be down near the AHU, or it might be in the switch room with a cable going to the AHU. So you need to be aware that your electrical colleagues, or if you're electrical and mechanical, that this sequence is properly sequenced in the schedule, and that we're pushing every day to make sure we have power available for our power on date for the AHU. We can't miss this date. Power on is what we're driving for. If we get here, we're doing well, really well. This is where delays happen. So there has to be, on the schedule, there has to be a cascading system. Power is cascading from an MV switchgear to the transformer into the main switchboard, down to your house mechanical distribution and into your AHU. Same with BMS, that the BMS cables are working, that the pre-power on is done. They have LV supply. Where is the supply coming from? You need to know what needs to be livened up upstream of the BMS. So you need to know this and learn it. Get your single line diagrams, get simplified single line diagrams. We always create simplified single line diagrams so everyone can understand very easily what needs, power and where it's coming from. Because, an SLD might be just too complex for a lot of people to read. So we make them very simple flow chart. This AHU number, whatever it is, number 15, and here's the distribution down to it. It might be dual supply, there might be automatic transfer switches. You need to understand all that. It needs to be in your commissioning plan how you're going to do this as well. The sequencing, if it's dual fed, are you turning one on now, are you turning them both on? What's in the switching plan also. And everyone's involved, and we have a power on meeting the night before we do power on. We go through all the paperwork, go through all the snags, make sure there's no critical snags. Everyone gets together last thing before you leave in the evening and agree that we can do power on in the morning. And then first thing in the morning, operations, whoever needs to be there, engineer of record, CXA, whoever needs to be there is there in the morning. We're ready to take locks off and power it on in a very safe manner. There'll be permit to work as well. You might need a permit to power on. You will need a permit. So there's a lot of things going on here. I'm not going to I could spend half an hour talking about this alone, but just make sure that you know that there's a lot happening. This is the top of the hill, really. Once we get over power on, we can get through level 3 pretty easily unless there's something broken. And no one can predict that. So that's a card that's in the deck. So we're not going to play the cards that are in the deck. We play the cards that are in our hand. And what's in our hand is that we can organize everyone to be here, do a pre-energization meeting, make sure in our commissioning plans that these are the documents that we're presenting for level 2. They're all on the CDE, they're all labeled properly, they're all nice and ready for inspection by the CXA. We're encouraging the CXA to do pre-inspections. We're talking about this for days in meetings before this happens. We keep talking about it to everyone, getting everyone ready, making sure there's pre-inspections done of everything that needs to be done before we get power to this. Ventilation ductwork might need to be cleaned, might need to be pressure tested, cable testing the comms cable, make sure everything's connected and working right in the BMS, and that everything is intact and clean and ready to go. Just a note on level 2 check sheets, or the main check sheet. So I would have one main check sheet that references the other check sheets or references the other documents. So again, try to keep it simple. We want a number of documents to achieve yellow tag, and one of those documents is going to be the final inspection. You can do it that way, or you can have the final inspection and bake in the other documents into it. I think it's better to keep them separate, but sometimes the client is applying these check sheets to you, so you won't have a choice, and maybe you're better off not having a choice, because then the decision is easy. But make sure that if they're standardized global check sheets, make sure that anything that is not applicable is discussed well in advance of the night before we turn it on. That we're not having a fight over, is this not applicable or is it? So we've listed out in maybe even an RFI, or we've talked to all stakeholders, item number 1.6 is not applicable. We've listed them out and this is why, and we've gone through it beforehand. Sometimes they want you to leave a comment in every check sheet, and if you're doing 20 AHUs or 20 whatever, it's going to take a long time to go into each check sheet and leave a comment saying why it's not applicable. And this will fall into the GC scope often, and just make sure that there's an allocation, a resource to do that. It's a pretty boring task, but there's someone there to do it if it needs to be, and it's priced and costed for, like time and money is going into this. Okay, that's enough for level 2. We've gone through a lot, well, level 1 and level 2, and a bit of pre-con. Next episode we'll do level 3, level 4 and level 5. There's a lot more to AHUs than I remember. So we'll break this into 2 parts so we don't melt everyone's brains. Okay, thanks for joining and see you soon.